We now discuss the solution of a problem from the section complex numbers. The given question is about the argument of the complex number z in the given context of a problem. This question has appeared in the joint entrance examination main held on 25th June 2022 in the first shift. The given question is, let a circle C in the complex plane pass through the points z1 is equal to 3 plus 4i, z2 is equal to 4 plus 3i, and z3 is equal to 5i. If z not equal to z1 is a point on C such that the line through z and z1 is perpendicular to the line through z2 and z3, then the argument of the complex number z, the argument of z is equal to, we are given four options. Option A, tan inverse 2 by root 5 minus pi. Option B, tan inverse 24 by 7 minus pi. Option C, tan inverse 3 minus pi. Option D, tan inverse 3 by 4 minus pi. We have a circle C in the complex plane that is passing through these 3 points. Z1 is equal to 3 plus 4i, Z2 is equal to 4 plus 3i, Z3 is equal to 5i. And given that Z not equal to Z1 is a point on C such that the line joining Z and Z1 is perpendicular to the line joining Z2 and Z3, then required to find the argument of Z from the given following four options. That is our given question. We now discuss the solution of the problem in detail. We are given a circle C in the complex plane passing through the points P, Z1 is equal to 3 plus 4i, Q, Z2 is equal to 4 plus 3i, and R is equal to Z3 is equal to 5i. That is, C is a circle passing through the points in P 3 comma 4. That is, this is the point corresponding to the complex number 3 plus 4i. So the corresponding point is 3 comma 4, P 3 comma 4, Q 4 comma 3, R 0 comma 5. Notice that mod z1 is under the square root of 3 square plus 4 square, that is 5. Mod z2 is also 5. Mod z3 is also 5. So it says z1, z2, z3 lie on the circle mod z is equal to 5. So the equation of the circle C is mod z is equal to 5. That is, in the Cartesian representation, we have x square plus y square is equal to 5 square. So that is the circle C in the complex plane, and P Z1, that is P 3 comma 4, Q Z2, that is Q 4 comma 3, and R Z3, that is R 0 comma 5. So that is the circle what we have. We now Z is a point on the circle not equal to Z1, that is not equal to 3 comma 4. and such that the line joining Z and Z1 is perpendicular to the line joining Z2 and Z3. Z2, this is Z2 and this is Z3, Z2 and Z3. From that, you have to find the argument of Z. Now, given Z not equal to Z1 is a point on C such that the line through Z and Z1, that means the line joining Z and Z1, is perpendicular to the line joining Z2 and Z3. So, this is Z represented by A and not equal to Z1. Z1 is 3, 4. So, the line joining Z and Z1 means A and P, AP, is perpendicular to the line joining Z2 and Z3. Z2 is Q, Z3 is R. That is, the line joining that one is RQ. So, let us say Z is X plus IY. So, let Z is equal to X plus IY given A, Z not equal to Z1, right? So, that is A X comma Y, right, in the Cartesian form, is a point on C such that AP is perpendicular to RQ. This implies the slope of AP multiplied by the slope of RQ is equal to minus 1. Right. The slope of RQ we know because 2 points are there. So, the slope of AP multiplied by the slope of RQ is y2 minus y1, that is 3 minus 5, by x2 minus x1, that is 4 minus 0, is equal to minus 1. And this is minus 1 by 2. So, slope of AP will be 2. Now, the slope of AP is known, and this line AP is passing through P, that is 3, 4. Therefore, the equation of AP we can write. That is y minus 4 is equal to the slope 2 times into x minus 3. When simplified, you will get y is equal to 2 times x minus 1. Good. So, what are we trying to do? That is Z is x plus iy with this property. We want to find the argument of Z. The argument of Z will be tan inverse y by x. That means we are trying to find what is this x plus iy. What is x? What is y? Once we get that x and y, we'll write tan inverse y by x. That is the slope of Z we can write. So y we got. Now a x comma y lies on the circle C. So that means A with coordinates x comma y is 2 times x minus 1 lies on this. So substitute in this for y 2 times x minus 1 in this equation, that is x square plus y square is equal to 5 square. So if substitution, so simplify, we'll get 5x square minus 8x minus 21 is equal to 0. So solve for x. X is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. Simplify, you'll get x is equal to 8 plus or minus 22 by 10. That is x is equal to 3 minus 7 by 5. Right. For these values of x, what is a y? So y is equal to 2 into x minus 1. And when x is equal to 3, y value is 4. When x is equal to minus 7 by 5, y value is minus 24 by 5 respectively. So that means a x comma y is either 3 comma 4 or minus 7 by 5 comma minus 24 by 5. But you know this point A, that is Z, is not equal to Z1. This 3 comma 4 is Z1. So it is given Z not equal to Z1. So A Z not equal to Z1 is given. So it cannot be 3 by 4. Therefore A x comma y is this only. So A x comma y is minus 7 by 5 minus 24 by 5. Since It is given z not equal to z1, that is equal to 3 plus 4i, that is 3 comma 4. And this is minus 7 by 5 minus 24 by 5. It will tell you that it is in the third quadrant, because both abscissa and ordinate are having the negative signs. So it is in the third quadrant. This is very important. So to talk about the principal argument of z, this is very important, very important. Now z is what? Now z is equal to minus 7 by 5 minus 24 by 5i x plus iy. Now what will be the argument? The tan inverse of y 24 by 5 by 7 by 5. That is the tan inverse 24 by 7. But you want the principal argument of z. The principle of argument of z is tan inverse 24 by 5 by 7 by 5, when simplified, tan inverse 24 by 7 minus pi. Minus pi. Why minus pi? Because it is in the third quadrant, and the principal argument is like this. So let's look at our options. Our answer, tan inverse 24 by 7, this is 24 by 7, 5 cancels, minus pi. So appears against option B. Therefore, the answer for this question is option B. That is the detailed discussion of the solution of a given problem, wherein you are asked to find the argument of z in a given context given in the question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.